When we have a circuit where there are more than one active devices, that is the voltage source or current source, then principle of superposition is helpful. So principle of superposition states that in a circuit when for linear condition, in a circuit when more than one active devices are present, response to any branch, that is maybe let's say for this one we are looking for the response here, what is the current here. So response at any branch is the linear sum of responses for each of the active devices. So just the sum of for responses for each of the active devices while making all other active devices inactive. So basically all the voltage source and current source are active devices, and resistance, capacitance and inductances are the passive devices. But we are restricting our discussion to DC. It is also principle of superposition is also applicable for AC, but we are restricting for DC, so we are not bringing the AC source or the inductances or capacitance. But anyway, in this condition, so response at this resistance, so when we say response, it can be current through a resistance or any element or voltage across it, so both are responses. Now if we look at the response here, the current I1, using principle of superposition, the principle of superposition says that first we need to calculate the I1 with only Vs1 while making everything else inactive, all the other active elements. So by inactive means we have to make it the voltage sources short and current sources open. Voltage sources short mean the definition of a voltage source is it maintains a certain voltage across its terminal, both terminals. So when we make it inactive, that means a short circuit, because short circuit means the voltage across it is zero. So that's the inactive condition of a voltage source. Similarly, the definition of a current source is that it maintains that current through this that source. So maybe if we look at this current source IS1, by basic definition, whatever it is connected with, it should maintain IS1 through it. Now in order to make it inactive, in order to make that current flow stop, we can open it. So making a current source inactive is in effect making it open circuit. So basically what we have to do is first we have to calculate that resistance, that current with only Vs1 active, so it will become something like this. So the current source is open, this one is open here, this voltage source is short here, this resistance stays the same, all the resistances stay same, so doesn't matter, and this one is open. So that is the thing. So already we can see that the current through IS1 will be 0. I mean, because this is an open here. But anyway, if there was a voltage source here or if there was nothing here, we had to calculate it. Similarly, for each of the sources, we have to calculate the current through IS1 by making each of the sources active at a time. And then the final one will be IS. So it is I1, sorry. So I1 for Vs1 plus I1 for Vs2 plus I1 for IS1, and then finally I1 plus for I1 for IS2. So we calculate the current through that branch for each of the active devices while making the other active devices inactive, and then we add all of them. That is what principle of superposition says. So we will do an example maybe later, but that's the theory. And even in this one we can see that because of this particular arrangement of the circuit, the current through this one, for when we consider Vs2 as well, the Vs2 will stay here, this one will be short, but this Is2 will be open, so there will be no current. So basically this current and this current will be 0, because in each of these three cases, this Is2 will be inactive, so this branch will be open, so no current can flow through this I1 and this R3. So only when the IS2 will be considered, other sources will be negative, only then this IS2 will flow through that. So basically I1 will be minus IS2, which we can say by mere observation, because this is a current source connected and it is connected in series. So basically the current source will maintain that current throughout the branch, because only here the current is changing, but otherwise it's the same. So this is so simple because of this particular arrangement, but it could have been something else. It could have been a voltage source here, so we had to calculate for each of the sources and then add them. So yeah.